Hello, wonderful NASA HUNCH Academy students and teachers. I'm excited to be able to introduce you today to our project called Plants in Space. And I want to talk a little bit about the reason we need to grow plants in space. And I'm going to show you some food items that we have sent up to the International Space Station because they are growing some plants in space, but most of their food we send up, and we have the food thermostabilized to last for 3 years. And we dehydrated most of the food so that it is as light as possible because it costs $10,000 a pound to send this food up to the space station. So this is a mango salad, and if you look closely, you can see directions are in English and in Russian because we share our food with the cosmonauts and others. What the astronauts do is they have warm and cold water, and here it's a mango salad, so they would add, and it says 50 milliliters of cold water, and leave it set for 5 to 10 minutes. And then once it's hydrated again, the astronauts actually have the normal utensils up there, but they also have a scissors. And the scissors will make an X on the food so that they have some flaps. And once the food is hydrated, the astronaut can put the spoon under the flap and the food will stick to the spoon. Everything floats on the space station, the astronauts and the food, so we have to have Velcro on the table that they eat and Velcro on the food containers so that the astronauts can put the food down and it will stick to the table so they can have their delicious mango salad. And one more thing I wanted to show you. You might recognize this. It's Cheerios and milk. The milk is powdered milk, and the astronauts would add the water, let it sit for 2 to 5 minutes. We don't want the Cheerios to get soggy. And then they could cut it with their knife in an X and use their spoon to have Cheerios and milk. The surface tension actually makes the Cheerios, once they're wet with the milk, stick to the spoon. I have a few more samples. This is a can. This is from the European Space Agency. It weighs a lot. And at $10,000 a pound, we don't send too many cans up. The Russians and the Europeans send up cans. For drink, if they want orange juice with their Cheerios and milk, we have, it says it's a hint of orange. It's actually Tang. And there's a little powder in the bottom here. They would add the water and then drink it with a straw. And they would have their orange juice in space. But because of the expense, when we go to Moon and Mars, it's going to cost a lot more. I always thought $10,000 a pound was a lot, but when I heard that it will cost $1.2 million a pound to send food to the moon, which is 240,000 miles away, the space station's only 240 miles away, but the moon is 240,000, and the Mars is exponentially further than that. So that we cannot send even these thermostabilized package. The astronauts are going to have to grow their plants on the moon or Mars or wherever they land up in space. So today, I'm introducing you to the projects that we are going to make that will help the astronauts learn about growing plants in space. And the first project is about growing plants on a sponge. So a sponge is a very light object, and our wonderful Brittany Kroger is going to walk you through the STEM challenge of growing plants, growing seeds in a sponge. The next project is called Tomatosphere, and Tomatosphere is a project that the First Seed Foundation has very generously helped my HUNCH teachers that they can apply to get 2 packages of seed. And I have an example right here. And one package, and we don't know which one, actually spent 5 weeks. The seeds in it spent 5 weeks in space. So they send up a whole bunch, thousands of tomato seeds, and let them up there in the space station in a microgravity environment for 5 weeks. And then they brought them back. They packaged them into these packages. One of these packages contained seeds that went to space for 5 weeks, and one of them has never left Earth. And what they want to see is when the plants first germinate. So is there a difference between the time that it takes the seeds that went to space compared to the seeds that stayed up on Earth? Is there a difference in when they germinate? And this would be important for knowing if we're sending seeds to space, and we need to know if that either increases or decreases the number of days it will take for the seeds to germinate. And here's one of the plants that I actually did plant from, this is an X1, and it's actually about 5 weeks now. But I had the seeds germinate from 5 days to 21 days. So there was a big difference. And I don't know which package X or Y went to space, but once you get your results and send it into the First Seed Foundation, they will let you know if what one went to space. And so you will be helping NASA learn about the germination of the seeds with that project. And this, then one of the other projects in Plants in Space is to let those seeds grow. I put a popsicle stick in, and this mark right here is the 3-inch mark, and it's way past that already. It's about 4 inches, and it's keeps growing on me, which is awesome. Okay, so that's what I wanted to tell you about the introduction. I hope you have a lot of fun with this. Eventually, you'll be working. The last project actually is working on growing plants in a nanolab, which is a small 4x4 by 8-inch container that we did send plants to space, to the International Space Station. Some students did, and the plants grew beautifully in this little nanolab. So I'm excited to see what you come up with. Thank you all so very much. And we will see you with talking about some of the investigation stations in this Plants in Space project.